awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. So welcome back. So dalam video kali ini kita akan discuss 4 lagi soalan berkaitan dengan linear motion graph. Tapi sebelum tu, right, so kita tengok dekat sini. Okay, saya ada tunjukkan ada 4 video bagi short notes animation. Kat sini ada 3 video, 1, 2 dan 3. Saya harap awak boleh tengok dulu video short notes animation sebelum cuba untuk jawab soalan dalam video kali ini. Ataupun you boleh juga tengok dalam video academy revision bagi tajuk kinematics of linear motion graph. Okay, dekat mana kita nak dapatkan semua video ni? Macam biasa, you buka YouTube and then you scroll ke bawah. You tengok dekat sini. Okay, semester 1 Physics Materials. So dalam chapter 2 Kinematics of Linear Motion, dekat sini ada short notes animation daripada video sesi yang lepas. Jadi saya tak letak semula video short notes animation bagi linear motion graph sebab tiada apa-apa perubahan. Okey, jadi boleh tengok dekat sana sebelum kita cuba example ataupun soalan dalam video kali ini. Alright, so jom kita mulakan dengan example number 1. Alright, so the first thing you must do is look at the graph. Okay, so this is the graph of ST graph. Okay, so now let's read the question. The motion of an object in a straight line is shown in figure 2. Okay, so determine the velocity of the object for the motions given by AB, this one, BC and CD. So remember that when we have a graph of ST graph, we can calculate the velocity of the motion, alright, based on the gradient of the graph. So let's start with the first question. So we start with question A first, okay? So we want to determine what is the velocity at this point from A to B, okay? So look at here. From A to B, from 0 second to 4 second. So the displacement is positive displacement. Alright, means that the object is moving to the right or the object is moving upward. Okay, so we can calculate the gradient of the graph. So when we look at the gradient of the graph, you can see here that the gradient from A to B is constant. Okay, so kalau kita katakan dekat sini, when the gradient is constant from A to B, that's mean the velocity from A to B is constant. Okay, therefore, okay, velocity of ST graph can be calculated by calculating the gradient. The gradient of ST graph. Okay, and then so we want to calculate A to B first, so we can write VAB is equal to, okay, kita tengok dekat sini, displacement at point B is 40, so final minus initial, right? So 40 minus 0 over 4 minus 0, so that the answer is 10 meter per second. Okay, so this is the answer for AB. And then for motion of BC, so VBC, we can straightly get this value of velocity since the gradient of BC is equal to 0. Okay, so it means that no gradient. Okay, ataupun kita kata apa kat sini, time ni adalah object at rest. Okay, so object at rest, so means that 0 meter per second for velocity from B to C. Okay, so object at rest. Alright, and then from C to D, okay, you can see, look at here, the displacement from C 40 meter to D. Alright, from 40 meter to D is 0, means that kalau kita nak cerita the motion, okay, look at here. Let's say this is point A. Okay, and this is point B. Okay, so from A to B, okay, this is 40 meter. Okay, positive 40 meter means that the object is moving to the right. Okay, and then when the object reach point B, apa yang berlaku? Bila dia dah sampai point B, dia berehat from 4 second to 8 second. Okay, rest from 4 second to 8 second. Boleh? And then what happen? Kita letak sini ni point C jugalah sebab dia berehat. Okay, and then what happen? Okay, the object is moving backward until point D. Point D adalah point yang sama lah. Dekat point A tadi. So, the value is also, this time, negative 40 meter. Negative 40 meter. Sebab dia kembali pada point dekat mana dia mula tadi. Alright. Okay. So, that's why when we calculate the velocity of the object, okay, the velocity of the object is equal to negative 20 meter per second. So why the velocity is negative 20 meter per second? Alright, so because the object is moving in negative direction to the left ataupun dia pusing balik, dia patah balik. Okay, so kalau kita tengok kepada kecerunan AB, the gradient of AB and CD, which one is the steeper gradient? Okay, siapa yang lebih curam gradientnya? AB ke CD? Daripada gambar aja ni kita nampak CD is steeper compared to AB. That means the velocity of CD is bigger than AB. Okay, nilai negatif menunjukkan apa? Nilai negatif menunjukkan objek itu patah balik. Okay, tadi from A to B is moving to the right, B to C, rehat sekejap, C to D, the object is turning back or moving in negative direction. Okay, so look at here. Okay, we can highlight the negative, means that the object is moving in negative direction. Okay. Tapi nilai velocity dia lagi besar. Maknanya nilai velocity dia lagi besar dekat CD compare dengan AB. Kalau kita tengok kecerunan dia pun, kita nampak kecerunan CD lebih curam daripada AB. Okay. And then question B, the total distance moved. Okay, remember. So when the question state here, distance means that this is a scalar quantity. Okay, so this is scalar quantity. Okay, so no direction. Scalar quantity means that no direction. Okay, so kita nak kira what is the total distance. So means that the object is moving in this direction to the right 40 meter plus another 40 meter. So we ignore the negative sign because negative sign showing you that the object is moving in negative direction ataupun kita kata negative direction ni adalah to the left ataupun ke bawah. Kiri ataupun ke bawah, right? Kalau kanan dan ke atas nilainya adalah positif. Okay, so B, so I can write that B. Alright, so now we want to calculate the total distance. So the total distance is actually distance from A to B plus B to C, but B to C, the object is not moving, okay? And then SCD, okay, means that from C to D. So you can write that SAB plus SBC plus SCD. Okay, so SAB is 40 meter plus 0, SBC tidak bergerak, plus SCD. Okay, SCD means that the object is turning back to the initial point, which is point D ataupun point A lah, kembali kepada 0 meter. Okay, but this is distance, so ignore the negative sign. So it should be positive 40. And then the answer is 80 meter. Okay, And C, the displacement. Okay, so when we calculate the displacement, we must consider the direction since displacement is vector quantity. Okay, so bila objek itu patah balik, so dia adalah negative, right? So S is equal to SAB plus SBC plus SCD. Okay, so this time is displacement. Alright, so it should be 40 plus 0 plus negative 40. Alright, and then the answer should be 0 meter. Kenapa 0 meter? Sebab this is displacement. Okay, kita kira dari mana dia mula. It start from point A to C, 40 meter, and then come back to point A. So another negative 40. So displacement, we consider the direction. So displacement is 0 meter. Okay, dekat mana dia mula? Dekat situ pula dia berakhir. So point yang sama means that the displacement is equal to 0. Alright, and then D, we want to calculate the average speed. Okay, remember the equation to calculate the average speed. Dia tanya average speed, bukan average velocity. Kalau soalan tanya average velocity tu lain lah. Okay, that's mean displacement akhir tolak displacement awal bahagi dengan time interval. Tapi bila average speed, okay, yang atas ini adalah total distance. Okay, total distance bahagikan dengan the time interval. Okay, so the total distance kita dah kira tadi 80 meter divide time dalam masa 10 second and then it is equal to 8 meter per second. Alright, so finish example number 1. So let's proceed to the example number 2. Alright, example number 2. So this time we have velocity against time graph. Okay, so let's read the question first. So describe the motion of the object in 10 seconds. Okay, so we want to describe the motion of the object in 10 seconds. But before we start, actually from this graph, we can determine the motion of the object. Objek itu bergerak ke arah mana? Alright, so now look at here. The object is start at this point. Okay, so kita ambil satu point lah. Okay, let's say the object start at this point. Okay, we name it as point A. And what happened to the object in 2 seconds? Okay, look at the velocity. Okay, the velocity is start from negative 2 and then it reduced to 1. Okay, kita tengok nombor dia saja. 2, 1, and then after 2 seconds, what happened to the object? Okay, V dia adalah 0. Maknanya dekat sini dia berhenti. Okay, tapi sejauh mana objek itu bergerak? Sejauh mana objek itu bergerak, kita boleh kira by considering the area under the graph. Look at here. Okay, we have the area under the graph. Kita boleh kira area under the graph ni kalau kita nak tahu objek itu bergerak sejauh mana. Okay, so let's say lah kalau kita nak kira from 0 to 2 second, okay, we can calculate the area under the graph. Okay, half, it is a triangle, right? Times negative 2 times 2, and then look at here, negative 2 meter. So kita akan dapat, okay, from 0 to 2 second, the object is moving to the left, negative 2 meter. Okay, kalau you nak tengok sini, saya selalu pesan pada student, you tengok nilai velocity kalau negative means that direction ataupun motion of the object is to the left. Kalau dia bergerak kiri kanan lah. Okay, means that to the left. Okay, so kalau saya lukis tadi point A, okay, maknanya objek itu bergerak in this direction. Ke sini. Sejauh berapa tu? Let's say point B. Kan? A, B. Okay, maknanya dekat point B ni dia stop sekejap. So sejauh mana? Sejauh negative 2 meter. To the left, right? So negative 2 meter. Okay. Negative 2 meter. And look at here, at this point, at point B, dia berhenti sekejap. Okay. Okay, dia berhenti sekejap. Lama ke dia berhenti? Sekejap sajalah. A to B. Okay, from here, start from A, negative 2 meter per second, and then slowing down, negative 1. Okay, still to the left, and then reach 0 meter per second, and then dia akan patah balik. Macam mana saya tahu dia akan patah balik ke point A? Okay, awak boleh tengok dekat sini. Okay, the velocity is increasing and the reading of the velocity is positive. Once nilai velocity itu positive, means that the object is moving in positive direction ataupun to the right. Okay, so start from here, 0. Okay, 0, 1, 2. Okay, maknanya semakin meningkatlah dia punya velocity. And then the value is positive. So means that it's moving to the right. Okay, kalau you tanya saya sejauh mana dia bergerak, saya perlu kira ini. Sejauh mana dia bergerak tu. Yang warna kuning tu kan. Okay, so kita boleh kira from 2 to 4 second. Okay. Alright, so the displacement is 2 meter. Okay, maknanya dia patah balik ke point A. Okay, so kita boleh lukislah. Okay, objek itu turning back to point A. Okay, sejauh 2 meter. Okay, so kalau kat sini saya letak, sini adalah point A balik. Okay. And then what happened? From 4 to 6 second, objek itu bergerak tak? Yes, the object is moving because V is constant. From A to this point, okay, kita letaklah nama point ni adalah point C. Objek itu masih bergerak with positive velocity. Bila positive velocity means that the object is moving to the right. Sejauh mana dia bergerak, saya tak tahu. Okay, tetapi saya perlu kira, okay, the area under the graph here. Okay, so kita perlu kira the area under the graph here. Alright, so from 4 to 6 second, okay, so it is a square. So means that the object is moving. Kan dia tadi dah sampai point A kan. So dia bergerak ke depan. Okay, look at here. Dia bergerak here. Okay, until point C with constant velocity sejauh 4 meter. Okay, daripada point A ke point C sejauh 4 meter. And then what happened? What happened? Okay, from C to D. What happened from C to D? Okay, from C to D, the object is still moving to the right. Kenapa saya kata object still moving to the right? Sebab nilai velocity dia masih positif. The object is moving to the right, okay, it continues its journey, but this time the velocity is decreasing. Daripada 2 meter per second at point C, the decrease to 1. And then at point D, is equal to 0. Okay, so sejauh mana dia bergerak, saya tak tahu. Saya perlu kira from 6 to 8 seconds. Okay, from 6 to 8 seconds, half times 2 is 2 meter. So dia bergerak ke depan lagi, bergerak ke depan lagi. Okay, so sejauh 2 meter. Okay, but at point D, okay, dia berehat. At point D, dia berehat selama 2 second. Okay, we can write here, at point D, the object stop. Okay, selama mana stop for? Stop for 2 second. Okay, so dia berehat sekejap, 2 second. Lepas tu apa yang berlaku? Okay, after 2 second, okay, dia dah berehat 2 second, what happened? The object is turning back or moving in negative direction. Macam mana saya tahu dia bergerak in negative direction? Because the value of velocity now is negative. Okay, so at this point is 0, right? This point, it is 0, and then the velocity is increasing to 1 and 2. Okay, but the value is negative because it's moving in negative direction. So daripada point D tadi, dia patah balik. Sejauh mana dia patah balik tu saya tak tahu. Alright, so we can calculate the area under the graph here. Okay. Alright, from 10 to 12 second. Okay, so it is half times 2 times negative 2. Alright, and then the answer is negative 2 meter. Okay, so negative 2 meter maknanya tadi dekat point D dia berehat selama 2 second, lepas tu dia patah balik sejauh 2 meter. Okay, so akhirnya dia akan sampai dekat point C. Okay, sorry gambar ni kecil sikit, you boleh lukis semula lah. So dia akan sampai balik dekat point C. Okay, daripada point D tadi, okay, dia berehat selama 2 second, lepas tu dia patah balik dekat point C. Akhirnya dia berada pada point C. Okay, kalau you lukis perjalanan dia, you akan nampak. Daripada graph V against T, you boleh tentukan the motion of the graph. Alright, so now let's try to write the motion of the graph dalam bentuk ayat. Okay, so we start with 0 to 2 seconds. Okay, 0 to 2 seconds. Okay, what happened? 0 to 2 seconds. Okay, kita boleh cakap apa? Object is travelling. Okay, tadi kita tahu kan? From 0 to 2 second, dia bergerak in negative direction because the velocity is negative. Okay, because the velocity is negative. So because the velocity is negative, so you can say that the object, okay, object is travelling, okay, in negative direction. Okay, in negative direction. Atau kita boleh tulis kata apa? To the left. Okay, with decreasing in velocity. Saya tahu dia decrease sebab 2, 1, 0. With decreasing in velocity. Okay, and then what happened? Jadi dia decrease velocity dia. Okay, secara apa? Uniform lah, acceleration dia constant. Okay, kalau kita kira gradient of the straight line graph ya, kita akan dapat nilai acceleration which is constant. Okay, and then what happened? Okay, then until here, okay, then it stopped after 2 seconds. Okay, we can write then it stops after 2 seconds. Alright, so finish. And then from 2 to 4 seconds, what happened? Okay. Ini saya tukar color lah. Okay. Okay, from 2 to 4 seconds, okay, the object is now, like tadi kita dah cerita kan, A to B, and then dia patah balik ke kanan. Okay, so kita nampak value velocity kita positif, so we can say that the object, okay, then moving in positive direction. Okay, which is to the right lah, to the right. Okay, to the right, and what happened to the velocity? And increase its velocity until 2 meter per second. Okay, with uniform acceleration. Okay, kalau ini kita boleh kata the object, okay, kalau kat sini kita boleh kata the object mengalami uniform deceleration. Okay, okay, kenapa uniform deceleration? Sebab V dia decreasing, 2, 1, 0, yang ni dia increase, 0, 1, 2. So gradient of the graph, you boleh kira acceleration dia lah. So uniform acceleration, this one uniform deceleration. Okay, so berbeza Okay, and then we can look at here from 4 to 6 seconds. What happened from 4 to 6 seconds? Okay, from 4 to 6 seconds, the object still moving. Okay, nilai velocity dia masih positif. Okay, we can say that object continues its journey ataupun still continue moving to the right. Okay, to the right with constant velocity. Kali ni dia bergerak with constant. Okay, constant velocity. Berapa nilai velocity dia? Velocity of 2 meter per second. Kita boleh nyatakan lah kalau kita nak nyatakan. Okay. So yang ni saya discuss detail supaya you faham lah. Okay, about the whole journey. Alright? Alright, so let's continue for another journey which is from 6 to 7 seconds. Okay, so from 6 to 7 seconds, okay, sorry, from 6 to 8 seconds. Okay, we can say that the object is moving, alright, the object is still moving, okay, from 6 to 8 seconds, the object is still moving to the right, but this time the velocity is decreasing from 2 to 0 second. Okay, so nilai velocity from C to D masih positif, means that the object still moving to the right. Okay, object moving, okay, to the right, but decreasing, okay, its velocity. Okay, so you can see here, if we calculate the gradient of the graph, we can get the acceleration, and the value of the acceleration is negative. Alright, because the velocity is decreasing and the object is still moving to the right, iaitu in positive direction. Okay, so decreasing its velocity, so you can say that the acceleration, okay, ini saya letak tambahan sajalah, acceleration is negative, okay, since the object, okay, ini tambahan lah, catatan tambahan untuk awak, decelerate. Okay, decelerate. Okay, acceleration is negative since the object is decelerate in positive direction. Okay, okay, acceleration negative because the object decelerate because V is decreasing, tetapi dia bergerak in positive direction. Okay, so kena tahulah yang tu. Alright, and then the object from 8 to 9 second. Sorry, 8 to 10 second. Okay, 8 to 10 second. Okay, the object is at rest. Okay, so the object is at rest for 2 second. Dia tidak bergerak. Okay, jadi soalan ni dia tanya daripada 0 to 10 second, but how if dia tanya sampai 12 seconds. Okay, so now look at this line from 10 to 12 second. Okay, kita tambah saja. Okay, sebagai tambahan lah. From 10 to 12 second. Okay, apa yang berlaku from 10 to 12 second? Okay, so at this point the object is not moving. So tadi kita tahu dia patah balik. Okay, here V is 0. And then what happened? The V is increasing. 0, 1, 2. But the object is moving in negative direction. That's why the velocity is negative. Okay, so from 10 to 12 second, we can say that the object, okay, the object is moving, okay, to the left or in negative direction. Okay, okay, but increasing in its velocity. Bila objek bergerak ke kiri ataupun bergerak in negative direction, but the velocity is increasing, means that the object is accelerating. Okay, dia memecut. Okay, sebab V dia bertambah, tetapi kalau kita kira nilai gradient ini, you akan dapat acceleration dia adalah negatif. Kenapa acceleration dia negatif sedangkan V dia increase? So always remember, Okay. Nilai A negatif bukan sebab objek itu decelerate. For this case, the object is accelerating and the value of the velocity is increasing. Tapi disebabkan objek itu moving in negative direction, so nilai acceleration dia akan jadi negatif. Jadi you jangan hafal sentiasa A itu negatif sebab dia decelerate. Bukan. Okay, dalam kes ini dia accelerate. Okay, dia bertambah dia punya V ni from 0, 1, 2. Boleh? Alright. So finish A and then B. So the question asks us to sketch a graph of acceleration. Okay, against time. So we need to calculate first what is the gradient for each section here. So here we want to calculate first. Okay, for B we want to calculate the acceleration. Okay, we start with the acceleration from 0 to 4 seconds. Okay, so acceleration. So V final minus V initial over the time interval in 4 seconds. Okay, so the acceleration is positive 4 meter per second squared. And then from 4 to 6 seconds, you can see here. Okay, this one is from 0 to 4. Kenapa saya kira sekali saja? From 0 to 4. Okay, you can see here, this is the straight line. So you can calculate straightly. Okay, what is the acceleration from 0 to 4 seconds? And then from 4 to 6 seconds, we already know that the object is at rest. Okay, so no gradient. Okay, so no gradient. Tiada kecerunan means that the acceleration at that point is 0 meter per second squared. Okay, so this is the value. Okay, and then from 6 to 8 seconds, okay, we can see here, so you can see here that the gradient should be negative. Sebab line ini kita nampak, this is the positive line, so that this is the positive gradient. Maknanya kalau you nak ingat, line macam ini, tak straight line. Line yang macam ini adalah positive value, line macam ini adalah negative value. Okay, always remember. So from C to D, from 6 to 8 seconds means that the gradient yang kita dapat nanti mesti akan dapat negatif. Okay, so mesti akan dapat negatif 8 minus 6 seconds. So the acceleration is equal to negative 1 meter per second squared. Okay, so this is the value from 6 to 8 seconds. And then from 8 to 10 seconds again, okay, the object is at rest. Okay, V is equal to 0. Okay, so kita tak perlu tulis lah. Kita tak perlu kira, tak perlu kira. No gradient, straight line, right? Horizontal line. No gradient, so acceleration is equal to 0. Objek itu tidak bergerak, V is equal to 0. Okay, daripada 8 hingga 10 saat. And then the last one, from 10 to 12 seconds. Okay, we can calculate here. Look at the pattern of the gradient. So this should be negative value. The gradient should be negative, means that the acceleration will be negative value. Alright, so A is equal to negative 2 minus 0. And then 12 minus 10. So you're going to have 1. Okay, negative 1 meter per second squared. So negative is very important. Alright, so ini pun kita dapat negatif tadi. Okay, make sure you consider negative. It's because we want to sketch our graph of AT graph. A in meter per second squared and then T. Okay, T is in seconds. So kita masukkan semua nilai time. Okay, the time interval tadi 0 from 0 to 0, 2, 4, 6, 8, 10, 12. Alright, and then the acceleration, we're going to have 4. And then here we have negative 1. Alright, that's all. Okay, so we can sketch the graph from 0 to 4 seconds. It is 4 meter per second squared. So dia akan jadi macam ni lah. Constant acceleration from 0 to 4 seconds. Betul tak constant acceleration? Yes, you can see here from 0 to 4 seconds, the gradient of the graph is constant. Okay, it is constant means that the acceleration is constant. Alright, and then from 4 to 6 seconds, the gradient is 0 because a horizontal line from 4 to 6 seconds means that the acceleration is 0. And then 6 to 8 seconds, it is negative 1. Okay. And then from 8 to 10 seconds, 0 meter per second squared. Okay, 0 meter per second squared. And then from 10 to 12 seconds, it should be negative 1 meter per second squared. Alright, so ini kita dah siap lah kita punya graph. And then calculate the displacement of the object in 10 seconds. Okay, so bila kita nak kira displacement of the object in 10 seconds. Okay, so ini saya padam dulu. Okay, sekejap Okay, so kita nak kira displacement of the object in 10 seconds. Soalan C. Okay, so displacement is a vector quantity. Alright, so we must consider the negative sign of the area under the graph. So from 0 to 10 seconds, so look at here, this is the area under the graph from 0 to 2 seconds. And remember, okay, the velocity is negative, so kita kena consider bila kita kira displacement. Alright, okay, so kalau saya tanya awak, distance, kalau saya suruh kira distance, calculate the distance of the object for calculate the distance of the object in 10 seconds. Jadi kalau you kira distance, you hanya perlu tambah saja nilai positif graf ini. Okay, maknanya ini jangan ambil negative 2, ambil 2 saja. Okay, the area under the graph, positive value only, plus this area, the whole area of this trapezium. Okay, alright. Tapi sebab soalan tanya displacement, means that displacement kena consider direction. So velocity kita negative here. So bila kita kira area under the graph, you must consider negative sign. Okay, so kita kira lah. Kalau saya nak kira kat mana ni? Tepi ni lah. Okay, so C, you want to calculate the displacement. Okay, so since we want to calculate the displacement, so let's write displacement S. Okay, sekejap S is equal to which one? S is equal to, okay, kita ada dua bahagian kan? Kita ada dua bahagian. Kita buat satu lah, yang triangle yang bawah ni. Oh, sorry. Okay, so saya akan buat yang triangle bawah ini dulu. So dia akan jadi half times negative 2 ataupun tinggi dia negative 2 times the base. The base should be 2 lah. Okay, and then plus trapezium. Tahu tak area trapezium? Half times the height of the trapezium should be 2, and then times the parallel side of the trapezium. This one. Ini parallel side dia. Ini adalah 8 minus 2, 6 plus 2. Alright, 6 plus 2. Okay, so S dia akan jadi negatif, ni boleh potong. This one should be 6 plus 2, 8 lah. Negative 2 plus 8. Alright, and then the answer is 6 meter, positive 6 meter. Okay, so this is the answer. Alright, tapi kalau soalan tanya you distance, dia akan jadi apa? Kita tambah. Let's say lah soalan suruh kira distance. Okay, so kita akan tambah lah. Dia akan jadi macam ni. Half times negative 2. Kalau dekat atas tadi ada negative 2, bila you kira distance, you kena ignore yang negative 2. Okay, so dia akan jadi 2 times 2. Macam tu saja. Plus, trapezium tadi kita dapat berapa? 8 kan? Trapezium tu positif, saya terus saja letak 8. So, distance travel by the object bukan 6 meter, tetapi 10 meter. In case soalan minta distance. Faham beza distance and displacement. Alright, so we stop here for question number 2. Alright, and then I think this video is too long, so we will continue another 2 questions in the next video, which is part 2. Alright, see you in the next video. Bye bye.